Okay, good morning. Welcome to
FunMath number 90.
FunMath number 90. Manipulating algebraic expressions. Okay, so we are following section 2.3 in Art of Problem Solving's pre-algebra book, and we're going to learn about two different kinds of algebraic expressions and ways to manipulate them. Okay, so first, expand these expressions. 3 times x plus 2, what does this equal?
This is 3x plus 6.
Okay, this equals 3x plus 6. And one way, very important way to check if you're doing these manipulations correctly is just pick a number. So what's a number to pick for x here?
Just pick 1.
1, okay, so I get 3 times, what's 1 plus 2?
3.
So 3 times 3 is?
9.
9. 9. That is right. Okay, what is 3 times 1 plus 6?
3 plus 6, which is 9.
9. Okay, very good. Okay, what about this? X times 2x plus 4, what does this equal?
Well, it's 2x squared plus 4x.
Okay, and let's pick a number to check here.
Let's pick 3.
Okay, so 3 times, what is 2 times 3 plus 4?
10.
Okay, 3 times 10 is?
30.
30. Okay, so this side is 30. Now,
2 times 3
3 squared is?
9.
2 times 9 is?
18.
4 times 3 is?
12.
18 plus 12 is?
30.
30, okay, so it looks good. Alright, so this is expanding these expressions or using a what is the property called when we take something and multiply inside the parentheses?
It's the distributive.
It's the distributive property. The 3 hits the x and the 3 hits the 2. Here the x hits the 2x, giving us a 2x squared. And the x hits the 4 also, giving us the 4x. Now, the opposite of the distributive property is called what?
Factoring.
Factoring. Oh, sorry. We are getting close to the point where it's difficult to erase.
I think we already are at that point.
We may already be at that point. Okay, so 5x plus 10, say we're going to factor something out of that, and let's factor something out of 2x squared plus 4x. Okay? What can I factor out of 5x plus 10 to make
5.
it? Okay, so what does this become?
5 times x plus 2.
Okay, 5 times x plus 2. Now let's pick a number and just check.
Let's pick 2.
2, okay, so 5 times 2 is?
10.
10 plus 10 is?
20.
20, okay. 2 plus 2 is?
4.
5 times 4 is?
20.
It's 9. I mean 20. Okay? Now, we're going to factor this as much as we can. What can we factor out of these expressions?
In x. Or actually we can factor out a 2x.
Here we can factor out a 2x. Okay? So I take 2x, and what am I left with this expression when I factor out a 2x?
X
Just x.
plus 2x.
Okay? Now, let's pick, what do you want to pick x to be?
Let's pick x to be 3.
Okay? So, 3 times 3 is?
9.
Times 2 is?
18.
So this is 18 plus
4 times 3 is 12.
12, and that's?
30.
30, okay. 2x is, x is
6.
3, so this is 6 times
3.
3 plus
X plus 2x is 3x, 9.
6 times 9. What is 6 times 9?
It's 36. No, 6 times 9 is 54.
No, 6 times 9 is 30. Oh, wait a minute, 6 times 9 is 54. Huh, maybe we made a mistake. Okay, that's good. That shows why checking is really important. Okay, so, something's wrong. Is there anything wrong with this?
No.
No, this is when x equals 3, this is 18 plus 12, and this is the original expression anyway, so it's not likely to be something wrong with the original expression.
No.
Okay, so let's go back and see. What happens when I multiply 2x times x plus 2x? What do I get?
Oh, you get 2x squared
2x squared plus
4x squared.
4x squared.
There's the mistake.
Okay, aha, there's the mistake. This is just x plus
It's just x plus 2.
x plus 2, because when I factor away When I factor out a 2x out of 4x, I'm just left with
You get 2x out of 4x, you get stuff with 2.
Right, because 2x times 2 is 4x. Now let's check it again. When x equals 3, this is 18 plus 12, which is 30. And I get 6 times
3 plus 2 is 5.
5, which is
30.
30. 30. Right?
Yeah.
Okay, that was good. I'm actually happy you made that mistake because it showed why checking is so important. Because 30 did not equal 54, right?
Yeah.
Because 6 times 9 was 54, not 36. In any case, definitely not 30. Okay? When we factor 2x out of this, we get 2x times x plus 2. Okay? Good job. Alright? We learned that checking is important. It saves us. Yay! Checking! Yay, taking extra time to check, because that helps you get the problems
Right.
right. Okay, good job.